Hello everyone. In this video we are going to talk about transfer function in computer graphics. So these are the topics that we are going to cover in our presentation. So first we are going to talk about the definition of transfer function. What exactly is transfer function in computer graphics? It is a mathematical function that maps input values to output values, often used to manipulate the appearance or characteristics of an image. It is a fundamental tool in image processing and visualization for controlling various aspects of the rendering process. The purpose of transfer function is to adjust or transform data values to achieve desired visual effects. Transfer functions can be used for tasks such as color mapping, contrast enhancement, filtering, and volume rendering. We have basically two components of transfer function. First is input domain and second is output range. Input domain represents the range of possible input values. In image processing, the input domain may correspond to pixel intensities, scalar values from a dataset, or other numerical data. And output range represents the range of desired output values. Depending on the application, the output range may correspond to colors, transparency levels, or other visual properties. Types of transfer functions are: first is color mapping transfer function. It maps input data values to output colors. It is used to assign colors to pixels based on their data values. It enables fast false color visualization of data and enhances visual understanding. One example of color mapping transfer function is mapping grayscale intensities to a color spectrum for scientific visualization or medical imaging. Second type of transfer function is contrast enhancement transfer function. It adjusts the mapping of input values to output values to improve image contrast. It is used to enhance the visual quality of images and make details more visible. Techniques such as histogram equalization, contrast stretching, and gamma correction fall under this category. Example of this type of transfer function is stretching the histogram of an image to increase the contrast between dark and bright areas. Next we have filtering transfer function. It transforms input pixel values to produce output pixel values based on a predefined kernel or mask. It is used for various image processing operations such as blurring, sharpening, edge detection, and noise reduction. It can be linear or non-linear depending on the kernel used. Example of this transfer function is applying a Gaussian blur filter to smooth out noise in an image. The next is volume rendering transfer function. It maps scalar values like density or opacity to colors and transparency levels for volume visualization. It enables the visualization of 3D volumetric datasets such as medical CT or MRI scans. It is used to assign colors and transparency based on scalar properties to create visually informative renderings. Example of this transfer function is assigning colors and opacity levels to different tissue types in a medical scan for diagnostic purposes. Then we have opacity transfer function. It controls the transparency or opacity of images in opacity of object in an image or volume rendering. It is used to selectively reveal or conceal certain parts of an image or dataset. It enables the creation of complex visual effects such as translucent materials or volumetric fog. Example of this transfer function is like gradually increasing the opacity of objects as they move farther away from the camera to simulate atmospheric effects. And an example of transfer function is like we can consider a grayscale image with pixel intensities ranging from 0 to 255, and a simple transfer function could map low intensities to dark colors, like low intensity correspond to dark colors and mid-range intensities to gray colors and high intensities to bright colors like white. By adjusting the parameters of the transfer function, we can control the overall appearance of the image, such as brightness, contrast, and color balance. So overall, transfer function plays a crucial role in computer graphics and image processing by providing a flexible and powerful mechanism for manipulating the appearance of image and visualizing complex data sets. They enable artists, designers, and scientists to control various aspects of image rendering and processing to achieve desired visual effects and convey information effectively. Thank you. That's it for the presentation.